Okay, hello. We on? Check, check, hello. Hello, hello. Alright, stream manager is on. Hey, Drewfish7, how are you? Hey, and done. Hello. Audio check, mic check. We good? Audio check, mic check. Hello, hello, hello. Need feedback. Is audio good? Alright, visual good? Okay. Good. Excellent, 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 excellent. Yeah, how's everyone's day going? Hey, vibes. The rock is cooking. Hey, Snoozer Kyle. You're here all the time. Man, I think Snoozer Kyle, haven't you been like a viewer for like well over a year, I think. Well, thanks for the following, and thanks for being a loyal follower for a long time. So, yes. All right. Hello, everyone. It is 4:30 Eastern Time here. Welcome. This is Introduction to Security. I'm Ming Chow, an Associate Teaching Professor at Tufts. Yes, this is actually an academic course at Tufts, but I open Thursdays up to the world on Twitch. And let me just say, I don't know if you all know this, but I thoroughly enjoy doing this on Twitch. Absolutely love every minute of doing this on Twitch. I just feel this is not only democratize education and learning, but also like especially if you're in the audience, and there's a lot of people. There can be a lot of people in the audience. No one knows if you're a cat or a dog. It's much better than sitting in a room of like 100 people, and then you get overwhelmed. Like, oh crap! I have a question to ask, but I feel stupid. Totally love doing these. Totally love doing this. No, I am not monetizing this channel, so like, no subscription, none of that stuff. I don't, no, I don't, no, I don't want to take advantage of people like that. No. Anyway, so today is going to be our topic is twofold. Number one is going to be one of the oldest tricks in the book, and unfortunately is still a major, and I mean major problem these days. That is called distributed denial of service attacks. And then we're going to go into, we're going to do a little bit of Python today, and we got a very special guest today. Yeah, we got a very special guest today. So we're going to do distributed denial of service, which will lead to Scapy and Python. And we got a special guest today, John Hammond. He's going to be doing a tutorial on Scapy. Not so much Python, but on Scapy, which is a module for Python. Right? Well, you can use to take down the internet with. Yeah. Yeah. So, what is a distributed denial of service attack? Well, okay, let's take a look at the last three letters of DDoS. Okay, forget the distributed part. The whole idea of a denial of service attack is take down a target, take down a computer, take down a network, take down a system, or take down a network, so it is inoperable by people who really need access to it. Okay, so the idea of the denial of service is really what it means in by language is deny service. And usually it's a critical service. We're talking things like website, email, medical system, scheduling system, I mean, you name it. Okay, but what does the first D in DDoS, and why is it called distributed denial of service attacks these days? And the whole idea of distributed denial of service attacks is use computers from all over the world, and have them work together to bring down a target, a system, infrastructure, you name it. So the idea of really of distributed denial of services, use a ton of computers, floods, just send so much traffic to bring down a computer, a network, an infrastructure, you name it. And here's an article from, here is a guide from Cloudflare. Cloudflare does a lot of work in security and how to mitigate DDoS attack for companies. So what is a DDoS attack? A distributed denial of service attack is a malicious attempt to disrupt the normal traffic of a targeted server, service, or network by overwhelming the target or surrounding infrastructure with a flood of internet traffic. That's it. Okay? And it's still a thing. I mean, this has been going on for not only years, but decades. Why is that? And the problem of a distributed denial of service attacks have gotten worse over the years, thanks to the proliferation of computers, and I would meaning cheap computers. I mean, we're not talking about desktops and laptops anymore. We're talking phones, webcams, toasters, thermostats. Uh, Basically, unfortunately, we've reached a point in our life where almost everything have to have a computer chip in there. And a lot of those devices were shipped and built insecurely. And lots of those computers can be taken advantage of. So here it says, exploited machine can include computers and other network resources such as Internet of Crappy Thing devices. Okay, and here's another little thing of, here's a little picture of denial of service. We've all been through this. I think some of you have even been involved in DDoS recently. Like if you're trying to get, unfortunately, if you're one of the few people who are still, many people who are still trying to buy a PlayStation 5. You go on the website, the time is on sale and can't get on. That's actually an example of a distributed denial of service attack. Okay, not a malicious one per se, but it's still denial. It's still a distributed denial of service attack. So I'm gonna go gloss through this because I did this in class on Tuesday, back on Tuesday. But how can you actually conduct a distributed denial of service attack? Like, what are the ways to actually conduct a distributed denial of service attack? Now, this does not include going to the dark web and renting out exploited computers, vulnerable computers that have been, riddled with malware, and then you can rent them for pennies on the dollar. That is one way you can do it. Let's not get into that one today. But let's talk about technically, how can you conduct a denial of service, a distributed denial of service attack. With that said, given that information, then we can actually go into, well, how do you really, really, really do it, like programmatically? Okay, so right now, there are three ways that you can conduct a distributed denial of service attack. One is actually by using Nmap. The caveat is if you if you use this incorrectly on Nmap, then you can conduct distributed denial of service attack, which is really what you don't want to do, especially because Nmap is primarily used for reconnaissance purposes. So one way to conduct a distributed denial of service attack is to use Nmap wrong by using what is called the decoy scan on Nmap. What a decoy scan is, you list out, you use decoys, which are supposed to be live computers and live IP addresses. So you specify a whole list of IP addresses that are to be used as decoys, which quote unquote makes it appear to the remote host or the target that the host that you specify as decoys are scanning the target network too. Okay, thus the target's intrusion detection system may report 5 to 10 port scans from the unique IP addresses but they won't know which IP address was scanning them and which were innocent decoys. This is a pretty effective way, as I said, for hiding your IP address. But here's the caveat, is that the decoys that you specify should be up and running and live. These IP addresses should not be unreachable, because if they are unreachable, then you run into two problems. The host that you hear it is that note that the host you use as decoy should be up, or you might accidentally sync flood your targets. Sync flood is an example of a distributed denial of service attack. Just have a bunch of computers just send a whole bunch of sync packets to a target, like over and over and over and over and over and over again, bring it down. Okay, so using Nmap decoy scan incorrectly, that's one way to perform a distributed denial of service attack. The other two ways are amplification attacks. The other two ways are amplification attacks. And this great article from Cloudflare, from written, well, actually almost a decade ago, describes how do you actually do amplification DDoS attack. This is the one that's still used up to this day. I mean, now you can be sending gigabits and gigabits and gigabits per second attacks thanks to this method. Okay, so back in the days, amplification attacks are a way to magnify the amount of bandwidth that they can target at a potential victim. Imagine you're an attacker and you control a botnet of sending out 100 megabits per second traffic. Well, that needs to be sufficient to knock out some sites offline. It is a relatively trivial amount of traffic in the world of DDoS these days. In order to attack your volume, you should try and add more compromised devices, machines to your botnet. This way it's increasingly difficult, yada, yada, yada. Do you need to know about amplification attacks? Yeah, absolutely. I mean, today, the examples that one of the examples that John will actually present using Python and Scapy is how to conduct an amplification attack using Python and Scapy. Okay? The original amplification attack was known as Smurf. Smurf attack used ping. A Smurf attack involves sending ICMP ping requests to a network broadcast address of a router to relay all the devices behind the router. Here's the key point. The attacker spoofs the source of the ICMP ping request to be the IP address of the intended victim. Since ICMP does not include a handshake, the destination has no way of verifying if the source IP is legitimate or not. The router passes, receives the request and passes it all along to all the devices that sit behind it. All of those devices then respond back to ping. Here's a nice picture of how a Smurf attack would work. Imagine if the victim IP address is 9.9.9.9, and all these devices are at 1.1.1.1, 1.1.1.1, 1.1.1.2, 1.1.1.3, 1.1.1.4, 1.1.1.5, 1.1.1.6. I'm the attacker. What I am going to do is I send to each and every one of these devices a ping. But the caveat is that the source IP is spoofed to be the victim, 9.9.9.9. So when each and every one of these devices actually receive a ping request, they will actually go and send a reply back to the victim. Because it says in the ping packet who the sender was. The sender was from the victim. All of a sudden, is that all these devices send do a reply to the ping, and the victim was going to receive all this traffic, all this ping data. It was like, WTF, like what the hell? And all of a sudden the victim becomes overwhelmed. Okay, so in this case, this is an amplification attack because we have 1, 2, 3, 4, 5 devices. So if you have 5 devices, 5 devices that are sent to the ping message, the victim will be hit 5 times. If you have 15 devices here, okay, if you have 15 devices, then there'll be 15 ping replies that will be sent to the victim. If you have 150 devices behind that received a ping, then the victim will receive 150 ping replies. It's like, what? Fortunately, Smurf attacks are largely a thing of the past. For the most part, network operators have configured their routers and not relay ICMP requests to a network's broadcast address. However, even as that amplification attack vector has closed, others remained open. The big one that still remains a bane of the existence on the internet is what is called DNS amplification. So here's the thing. Here's why ping works. Ping is, you can't ping a port. So ping is on layer 3. ICMP is on layer 3 of the OSI model. There's no handshaking. There's no handshaking, no port. And that means you can actually spoof the source IP address. You can forge the source IP address to be anything that you want. Okay? And you also need a way that actually will send data back to a victim. Ping is it sends only really small data. But what happens if you send like a really lots and lots of data? The domain name systems, DNS, which is the yellow pages of the internet, is a good criteria for an attack vector because, well, query can be set with a spoof source IP address because actually DNS generally uses UDP. That does not require a handshake. Whoever it was on the on Twitch last week asked if UDP required a handshake. That was a fantastic question because it leads up to today. And the response to the query is significantly larger than the query itself. DNS queries are actually transmitted over UDP, though, meaning like ICMP queries using Smurf, they fire and forget. As a result, their source attribute can be spoofed and the receiver have no way of determining its veracity before responding. Here's the beautiful thing about DNS and why it's used still so much for distributed denial service, is DNS is capable of generating a much larger response than the query. So imagine you just send this query. It's only quite a few characters, but you get this gigantic response. This gets sent to the victim. All this stuff. That's a 64-byte query that results in a 3,223-byte response. In other words, an attacker is able to achieve a 50-time amplification over whatever traffic that they can initiate over DNS resolver. Okay, so I just briefly glossed over 3 different ways on how you can actually conduct a distributed denial of service attack. One is by using Nmap, decoy scan incorrectly. 2 is by using Smurf, which is kind of a thing of the past. And number 3 is to use DNS amplification. All 3 of these techniques, decoy scan in Nmap, Smurf, and DNS amplification, they all have one thing in common. The one thing that they all in common is that, you're sending a lot of network traffic, okay, using spoofed or forged IP addresses, source IP addresses. So you may be wondering now, is there a way that I can create a network packet that have a spoofed or forged source IP address? I can set the IP address of the source to be anything that I want. And the answer is yes. The answer is yes, you can. And this is this is the real big gist of today, is using Python and Scapy. I want to introduce to you Scapy. Yes. Scapy.net. Okay, the Wikipedia definition of Scapy is a packet manipulation tool for computer networks originally written in Python. It can forge or decode packets, send them on the wire, capture them, and match requests and reply. Looks like pretty damn cool. Actually, here's the website, Scapy.net. Yeah, packet crafting for Python 2 and Python 3. Really now, here is one very important thing to keep in mind. Now Python 3 is a standard. Python 2 is deprecated, so you want to be using Python 3 for this. And here it is. Scapy can easily handle most classical tasks like scanning, traceroute probing, unit test attacks or network discovery. Can replace It can also handle a lot of different tools and tasks well. Scapy is platform independent. You can use it on Linux, Windows, Mac OS. Most Unix systems with libpcap. Uh, there is a shell demo to download Scapy. Okay, so if you're on Mac OS, I'll fire up a terminal. If you're on Mac OS, you better want to make sure that you're using Python 3. Now, if I'm not mistaken, on the latest version of Mac OS, a lot of the developer tools are not installed. Even if they were installed, Apple was always they always installed like the old versions of Python and the old version of C compiler. What I strongly recommend if you're on Mac OS land, if you're on Mac OS and you will be using a lot of software packages, I strongly recommend Homebrew. Homebrew is what is called the missing package manager. Okay, so you can use package manager. You can install basically any software that you want on the command line. You can even install things like Firefox, Chrome, Visual Studio Code, Slack, all of your favorite programs using Homebrew. Here's your instructions. Oh, no. 2.7 is no bueno. 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 Homebrew installs the stuff that you need that Apple or your Linux system didn't. Okay? So, strongly recommend. This is like Homebrew has basically been my go-to to install anything that I want. So install Python is brew install Python 3. And so if you do this, watch what happens. I already installed Python 3. Now, this is when one of the things that gets really hairy is that there are multiple versions of Python 3. There's Python 3.9 and 3.10. I don't care which one you use. Okay, unfortunately on my system, I'm using both versions of Python 3.9 and 3.10 because of special software I need. Okay, so the first and foremost is, if you're on Linux, I think Python 3 is installed by default, but if you're on Mac OS or you're on Windows, you gotta install Python 3. No ifs, buts, and then. Yeah, if you're on a Windows device, yeah, you gotta do this. Python 3 for Windows, download the binary. Python.org. There you go. You're on Windows. You can't use it on Windows XP or earlier. Sorry. Windows XP was a great system. So wasn't 7. Those were the ye good old days. There you go. Use one of these. You're on Windows. Okay. So once you actually have Python 3 installed, you would then do something like, I don't need to do this, pip3 install Scapy. Sometimes, I think on Windows it may be pip install Scapy, but now I think for clarification purposes on some systems it's pip3. So to install Scapy is pip3 or pip install Scapy. Hit enter and it will install. Take like a second or two to install. Kind of small. Okay. So you got to install Python first. Then you install Scapy as a module. What pip in Python is, well, for those of you who don't know, it's a package manager. So a package is like a library, and like every programming language have a package manager. Node.js for JavaScript has npm, Ruby has a gem, and there's a couple of different package managers for Python, but pip used to be the most popular one. What is pip? Not a pip. Yeah, here it is. Pip is a package manager for Python packages for modules, if you like. Okay. So, gotta install Python first, then Scapy by way of pip. All right. So, the next thing is, what can we do with Scapy? How do we run Scapy? Once you install Scapy, there are two ways to use Scapy. The first way is to use what is called the command line or shell demo. Okay, primarily that's not what we're going to use. What we're not going to use, because a lot of time we're going to be writing code. Okay, so one way to use Scapy is, once assuming that you have installed Python and Scapy correctly, you can test if Scapy was installed correctly if you just type in Scapy. Hey, Anchor. Oh man. Yeah, I think in the past, like everyone's complaining that the documentation was terrible. It's kind of a both, but this time I'm going to add some instruction on how to read the fine manual. So to see if Scapy was installed correctly on your system is just type Scapy, hit enter. And this is what you call shell or command line mode. Okay? Don't worry about these warnings. Okay. This is where you can do like a few line, you know, why you want to use a shell mode is, okay, if you want to do a few commands, a few lines of code, and that's it. Okay, and actually if you want to do a shell demo, you run this. So here is the shell demo that was provided by Scapy. So you have a variable p equals IP, which is the IP part of a packet. Set the destination to be equals github.com. You can even fit an IP address in there as well too. So this is the layer 3 of the OSI model, and then followed by a slash, and then your different layers. In this case, ICMP means a ping packet. Actually, I'll just do this example up. So what this will do is I'm going to create a packet called P, where the source is going to be automatically filled in, but the destination is going to be github.com. So if I type P again, so this is an IP packet. Protocol is going to be ICMP, also known as ping, and the destination is going to be the IP address of github.com. So what this is really, you got to be pinging at github.com. And then if you do SR1, well, you can also use send as well too. So what this is going to do is send a packet. So you're going to get one ping, you're going to send one ping packet to github.com. There it is. Finish sending one packet. Receive 41 packet. Interesting. And then if you print out R, you can see the echo reply from GitHub. So GitHub's IP address seems like it's 140.82.113.4. Is a command line command to install Scapy the same for Mac? Yes, it is. With one caveat. It could be either pip3 or pip. Now I'm going to open up a new tab. On my Mac, if you're using Homebrew on Mac, it's pip3 install Scapy. On Windows, read the manual. It could be either pip3 or just pip. Can be inconsistent. Yep. But generally speaking, it's the same command. Yes, that will work. Yes. That, if you're a Linux person, sudo apt install Python 3 Scapy also works. Yeah, absolutely. Yeah. Slapcake. Yep, absolutely, that will work. Yeah, that will work as well. Okay, so now, I mean, using the command line is okay. You know, using the command line is, alright, you want to do some like simple examples and stuff. I want to fire Wireshark. Okay, so I'm going to open a Wireshark for a reason. So I am going to capture on my Ethernet, which I'm currently using for EN5, Watch this. Oh, shoot. A whole bunch of things, but I only want to filter out ICMP traffic. Okay, nothing. Good. What I'm going to do is I'm going to create a ping packet from my computer to my Pi hole. So how you do that is the following. Packet equals, well, specify the IP headers. SRC equals, I can leave the source out if I want, but I can do the destination equals 192.168.1.10. And this is going to be an ICMP, a ping packet. So watch this. So if I'm going to hit send packet, you can also do SR1 packet. Watch what happens to Wireshark when I hit enter. Bang. Sent one packet. Oh shit. My bad. 192. My bad. Yeah. I can send the destination to be anywhere. Alright. In this case, I'm saying to 129.129. That's my bad. My bad. So I am at 192.168.1.244. And my destination, I sent a ping packet to 129.168.1.10, which of course I didn't get a reply back because I don't think that IP address is working. Send a packet, boom. There we go. Now this one works. So I am at 192.168.1.244. I sent a ping packet to 192.168.1.10. Sent a request. And I do get a reply back from 192.168.1.10. And I get a reply back. Back to me. Well, it works. Yeah. Yeah, capturing packets is fun. But now, here's a fun one. Alright. So, wait a minute. What about this you were talking about, which people might be remembering? Didn't you talk about forging packets? And the answer is, yes, I was. You want to forge a packet? All you have to say is SRC. The source can be any IP address that you want. Separated by a comma. Just set the source to wherever you want. Send. Watch this. Oh. What? Send missing. Oh, send packet. Sent one packet. Ooh. Look at that. 34.170.8.147. Yes, that's a live IP address. Sent a ping packet. It's interesting how Wireshark will actually will record the request. But of course, for obvious reasons, because this computer is 192.168.1.244, we did not get the reply. Interesting. What happened if I actually changed the packet from 192.168.1 to 192.168.1.244? You can send, you can set the IP, the source and destination to be anything that you want. Send packet. Now if I sent the packet, now it gets interesting. Ooh. Sent the request. Huh. Weird. Sent one packet. Nothing. Weird. Interesting. So all you want to do, if you want to forge a source IP, all you have to do is just set the SRC in the IP layer to be whatever you want. That's all you got to do. These are the simple exercises that you can do on the command line or what they call the shell version of Scapy. But generally speaking, what a lot of people will do, you're going to be writing a Python program. I don't need Wireshark anymore. Actually, I do. I want to stop and quit without saving. I will bring back Wireshark in a bit. But what if generally speaking, what you're going to use, how you're going to use Scapy is, programmatically by way of a Python program. And this is an example Python program that uses Scapy. So the actual full source code of this is available at right here. It's on GitHub. I'm going to do a few modifications for this program today. So here's how this program works. A working Scapy program. This is a working Scapy program that sniffs traffic on either a live network or from a PCAP file. Goal is to expand this to identify basic vulnerabilities such as credentials and plain text. For students in my security class, this is your fourth lab. Is to just modify this. And the only thing that you have to do is to modify one function, packet callback. This is the only thing that you need to do. You don't need to write good code and like modularity, none of that stuff. I do not want you to do that because that will make things a lot slower. Don't go overboard and don't, write terribly good code. You don't want to do that. All you need to do is modify packet callback, the function. So how this program works is that the function takes in one packet, and this packet callback is run each and every packet it sees. The base program that I provided is if the packet is TCP and you're seeing port 80 as a destination port, you just print out, okay, HTTP web traffic was detected. Take care, man. Always good to hear from you. So, how do you run this? I have a copy of this on my desktop, along with a few PCAP files. Alarm.py, set1.pcap, simple.pcap. To run this, you would do Python. In my case, I have to do Python 3.9 because I'm running two different versions of Python. Alarm.py. By default, if you actually don't specify any flags, you're going to be sniffing on the live network on ETH0, which my Mac does not have. So there are two modes in Python in this alarm program. The first mode called interact is a live sniffing by way of -I flag, and then you specify like your network adapter by way of ifconfig. Sniffing on the S5. Ooh, seeing web traffic somewhere. Okay, or you can actually use the alarm to open up PCAP files by way of a -R. -R, I'm going to open up simple.pcap. Just a reminder what simple.pcap looks like. It was that PCAP that we did on the second day. There are 1, 2, 3, 4, 5, 6, 7, 8 packets here. Of course, there is no port 80 here, but shouldn't print out anything. Yeah. Reading PCAP file, simple.pcap. All right, fine. What if I did this? Now, if I want to modify this and open up, okay. What if I did this? If packet sub TCP, which if the packet is TCP, go to the TCP layer. The D port equals, how about 7777? Instead of web, let's print out instead of web traffic detected. Well, port 7777 is detected. Yeah, save it. Now watch what happens. We're actually going to open up use alarm.py detected port 7777 wasn't a destination anywhere in simple.pcap, and the answer is yep, port 7777 is detected. Cool. All right. All right, all right, all right. This is nice. This is nice. All right, so I did my very first example of how do you detect packets with certain ports. There should be 1, 2, 3, 4, 5 packets with that mentioned 7777. One, yep, as a destination. 1, 2, 3, 4, yep, 5. Nice. If you can do source, you can also modify the program to show if the source port, S port, if the source port is 7777, see what happens. We should only get 3 results back. Yep, there you go. Nice, we got 3 results back because there's only 3 packets here in simple.pcap with source port 7777. Nice. Alright. Alright, what else can we do with Scapy? Well, my friends, let's take a look at the documentation. Now, this time, I have this documentation that I'm going to share. And this documentation has all the functions that you can use for a single for a single packet. It's a lot of stuff here. Now, here's a reminder. Not every packet is a TCP packet. I mean, if you're working with complicated PCAPs, I mean, you could be having a UDPs, which is not TCP. So one of the things is function that you can use is has layer. So one shorthand that I use is if packet that's sub TCP. Should print out 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. There's 8 packets. But what it really is, what this shorthand can be written as, this is shorthand for has layer. If a packet has layer TCP, print packet as TCP. Do it again, same results. 8 times. Nice. Good. Okay. What happens if you do this? Okay, if a packet has a layer TCP, can I print it out? Yeah, sure. But I'm going to do this the wrong way. Print out, what the hell? Just a lot of, I can't understand all this. Well, here's why. The preferred method of printing out the details of a packet is show. Show prints or return a hierarchical view of a packet. Yeah. So if you want to show a packet, all the details of packets of show. All you need to do, no printing necessary. So if I do this again, boom, you see all the hierarchical data of a packet. The IP, yeah, look at that. At the very top. I'm going to scroll to the very top. There it is. Start at the very top. You can see all the IP header information. This is for the first packet in simple.pcap. S port, destination port, sequence. You can see the acknowledgement numbers. Look at the flag, SEC. There's first flag, yep, SEC. First set. Yeah. This is where you're gonna, okay, if you want to actually just print out the TCP flags, all you need to do is this. Instead of packet.show, is print packet TCP flags. This will print all the flags. Okay. Sync, yep. Print out all the TCP flags, for each and every packet. Yeah. To run a Python file from the terminal, it has to be in the working directory. Yeah, it has to be in the working directory. Why is TCP as a layer? Yeah, why is TCP referred to as a layer? Remember the OSI model, Amy? Remember the OSI model. There are how many layers? Actually, let me go back. If I do packet.show again. Okay, let's go at the very top. Okay, here we go. Ethernet, layer 2 of the OSI model. IP, layer 3 of the OSI model. Layer TCP, this is layer 4. So that's why it's called layers. Okay, sometimes we actually just say shorthand TCP packet. You can say that as well, but it's really not correct. TCP, IP, Ethernet are all layers, like layers of an onion, because it matches what is seen in the OSI model. See, the source and destination port are not seen in the TCP layer, but in the IP. Also, you will see payload as well too in TCP. Yeah, there you go. Interesting that the payload is in another layer called raw. This is where you can get the textual information. Okay. So I've given you a lot of, for those that are in my regular security class, I've given you quite a bit of information. Quite a bit to get started with the lab. You can see the breakdown of an entire packet now using Scapy. A lot more that you can do with it. But I'm not the expert. I'm going to turn it over to the expert. And I want to introduce to you now to John Hammond. Yeah, I'm going to turn it over to John. Oh. Come on.
Alrighty, hello everyone. Welcome. Thank you for tuning in. I appreciate you being here. This is a talk and presentation titled Take Down the Internet with Scapy. I'm presenting this as part of DEF CON 28 or DEF CON Safe Mode, and I'm here at the Packet Hacking Village. So let's dive into the presentation, but before we do, I've got to say this. I've said it before, I'm about to say it now, and I'm certainly going to say it again many, many times throughout the presentation. Thank you. Thank you for being here. Honestly, seriously, like, I know things are a little crazy and weird and not how we're used to them being at DEF CON, but thank you so much for being here. Thank you for tuning into this talk. Thank you for being a part of all this. I usually say this at the end, and I'm certainly going to, but now especially, I think it's really important. Just thank you. Thanks for being here. I really, really appreciate it. Okay. So the classic disclaimer, right? The start of every talk, it's just how it's got to start. These are my words, not my employers. I don't represent them. I'm not speaking for them, etc. This is stuff that I wanted to bring to you, me personally. Other disclaimer, don't or do try this at home, right? Anything that we talk about, anything that I showcase here, obviously it's a talk titled Take Down the Internet. Don't actually do that, or maybe do it at maybe your own small scale lab environment, etc. You can tinker with it and explore with it, but don't actually take down the internet, right? Cool. Next, your mileage may vary. I bring this up with everything that I kind of try and showcase. Look, I'm talking about it and I'm showing it to you. Maybe you'll have different results. Maybe something will work differently or strangely in the way that you do it if you do this sort of thing. I can't promise, and I don't mean to make this any written in stone gospel or anything. The stuff that comes out of this talk, it might be different for you, and your mileage may vary. Okay, last bit. We're the good guys here, right? We talk about security, we talk about cybersecurity, we break things for the sake of making them better, we hack for good. And I want you to do the same. The stuff that we're going to talk about and showcase in this presentation, maybe it's a little bit on the different side of the fence. I want to reiterate to you and kind of enforce it, hey, hack for good. Okay, obligatory introduction, right? Who is this guy talking at you? Hello, my name is John Hammond. I'll try and run through this quickly because I know no one cares, not even me. I used to just do some stuff with the Department of Defense Cyber Crime Center and their Cyber Training Academy, and I also work with like the Defense Threat Reduction Agency, as a kind of a red team cyber operator. Right now, I'm working as a senior security researcher over at Huntress Labs. Again, not speaking for them. These are my words, not theirs. And in my free time, I like to play a little bit of Capture the Flag. I like to develop and create and host Capture the Flag events or competitions or exercises and training sets to try and make people better, to try and improve everyone's cybersecurity skill. On that same coin, I do produce some cheesy YouTube videos. I publish and showcase some Capture the Flag write-ups or programming tutorials, video guides, stuff like that. But that's all nerdy stuff that you don't really have to care about. Let's talk about what we're going to talk about. Kind of meta, right? So here's the agenda, the roadmap, the outline for our discussion. First, we'll lay the groundwork. We'll put down a little bit of a background, really set the scene for what we're going to be discussing. I'm going to be talking a little bit about Python, right? Python's kind of my weapon of choice, but we needed to make a distinction between Python 2 versus Python 3 and what we'll kind of be using as our vessel throughout this talk. Then I'm going to introduce Scapy, one really, really cool Python module or library that you can pull into your Python source code, use with your projects, your other scripts, whatever you're working on to do really, really cool low-level stuff with network packets, with the stuff that you would find in PCAPs, if you were taking a look at it in Wireshark or TCP dump, etc. We're going to do that with Scapy inside of Python. So we'll talk about how to install it, some documentation, syntax, and use cases, etc. Then we'll get into the real meat of the conversation. We'll talk about different attacks that we could perform, and we'll kind of zoom in or zoom out as appropriate on some of these different things: the ping of death, the SYN flood, DNS attacks, BGP, etc. I do want to showcase a couple of IRL or in real life cases, right? Stuff that we've really seen out in the real world that is real. All about the stuff that we're kind of laying the foundation with here, Python, Scapy, and these network attacks when we're trying to take down the internet. We'll also discuss some of the defense and mitigation, some things that we could do, some things that we might consider when we take note of all these network attacks we're going to be looking at. Finally, I'll showcase some of the resources and references that I use to put together this conversation, this talk for you, and we'll have the boilerplate template slides, how you can contact me, and of course, I will thank you again and again. I'm really, really appreciative that you're here. All right, let's get into it. To get things rolling, let's lay the foundation. We're going to be talking about packets, right? We're here in the packet hacking village. We're talking about network-oriented stuff. So naturally, we're going to be talking about packets using Scapy, using Python, and we'll dive into that more. But I want to say the title of this talk, right? The whole theme, take down the internet, that's going to be doing a lot of kind of jerk stuff. It's about obnoxious, annoying, adversarial, and disruptive attacks. So nothing like elite, super cool, 0 days, crazy like Ninja Warrior, cyber hacker stuff, but really just being mean and breaking stuff. We're trying to recklessly break stuff. I want to showcase some of this to you because really I want to show you just how easy it is and how Python, just the same scripting language that's about on every Unix system, can do this stuff. And how you could do it if you really wanted to, but you shouldn't. You don't have to, right? Take down the internet, obnoxious, annoying, adversarial, and disruptive attacks. That's the background. All right, now let's talk a little bit about Python. I'm going to be using Python as the vessel for this talk, right? We want to make this a little bit of a technical talk and showcase some code, showcase some real stuff, rather than just pointing at numbers on a graph. So I want to lay the foundation again with Python. Python is a wonderful hacker's language. Yes, it's a scripting language. It's not compiled. It's read through an interpreter, but it is easy to read and easy to write. That means that it's super duper friendly. It's really easy to knock out quick testing scripts or to rapidly prototype some ideas. It's just handy and useful and has a lot of support between all the different libraries and modules and packages that you could pull into your code and do some really, really neat stuff. So there's some conversations, right? Because now we are in a new era. We are in 2020 and Python 2, the older version of Python, is dead. It's not on the table anymore. Python 2 reached end of life at the start of this year, and now Python 3 is the officially supported version. Please don't hate me for screaming about that. I just want to make sure, hey, everyone knows we're using Python 3 and you should be too. And of course, Python is part of Linux. It is typically shipped and natively kind of built into a lot of common Linux distributions. And honestly, you should be using Linux. I don't know why you wouldn't be. And because it is part of Linux, it's really, really easy to access it just from the command line. You can simply type in Python, and then you're inside of an interactive shell or interpreter to work with the Python language. I'm kind of being explicit here. I'm using Python 3 with that suffix 3 at the end. You probably will just be able to invoke it as regular Python, and maybe that would spin up Python 3 for you. But if it does, fire up Python 2. Hey, you should know better. Go fix that up and hop over to Python 3 now as the officially supported version. Python, while we could be working inside of the language within the interpreter or within that shell, oftentimes you'll likely want to create a script or file with a .py extension, maybe a shebang line, and you can invoke it and run it with Python just as an automated tool, not manually working through the interpreter or the interactive shell there. In a lot of our conversations, what we'll be discussing, I am assuming you're going to end up using this inside of a script with a .py extension, and you don't need that interactive interpreter. Okay, let's move on because you probably all already know about Python, and this is boring. So let's talk about Scapy. Scapy is incredible, fantastic, phenomenal. It is a module, it's a library, it's something you can just install, pull in to use with your Python code, and it gives you the ability to craft network packets. You can customize them, you can forge them, you can create them, you can whatever you want, your wildest dreams, whatever sort of network layers or protocols or things that you want to use, you can get that fine-tuned, like zoomed in microscopic customization of what that packet looks like. And that's super duper cool. It's easy to install. I'm showcasing some commands here. I'm assuming, okay, a Debian-based distribution, maybe Ubuntu, you'll do a little sudo apt update, and you'll install pip if you're working with that little handy Python package manager, and let's use pip install Scapy. Now, you could run Scapy in one of two ways, very, very similar to what we talked about in Python, right? Scapy could be interactive, and you could work inside of an interpreter with a manual, like typing in commands and getting that return back to you, like interactive shell. Or you could work with it inside of a script and have Python just import Scapy as a whole module, and you can access all of the code, the functions, the variables, all of that functionality that Scapy offers inside of your Python scripts, inside of Python. Now, this is crazy cool because we can work with TCP packets, UDP packets, any other network stuff, maybe CAN bus protocols or Bluetooth. There's so much more, and we could dive into some of the documentation for Scapy. I always want to point people to the real documentation because that's where the real stuff is, right? I'm not going to be the expert, sorry. I don't think you would call yourself the expert, and I'm not saying that to be mean. I'm just trying to say the source code is the truth, right? Documentation is the real accurate stuff. That's what's really there, really built in, and the official source, it's what's good to go to when you need help or you're trying to learn something new. Obviously, there's a man page for the command if you wanted to fire that up. Obviously, they've got an online web presence. You can check them out at scapy.net. And they have official documentation over at readthedocs.io. And of course, a GitHub page. So you can go take a look at the source code. It's open source. It's awesome. It's all Python, good stuff. The website is actually fantastic. They have a page over there called Awesome Scapy, and that will showcase other tools, exploits, and some sample code to use. And it's really, really cool. They have some good stuff on Wi-Fi, like mapping and tracking Wi-Fi networks through 802.11, making a roaming access point, performing some man-in-the-middle attacks, some Tor, onion router protocol stuff, tons and tons of great stuff, even CVEs and exploits for common attacks, or stuff from Crack, the attack against WPA2. Super duper cool. Really recommend you go check that out. Okay, now let's talk about the basic syntax of Scapy, because if we want to use it, we have to know how to. I say that Scapy is Pythonic in that the syntax that it uses when you're working with the module, you're working with Python objects, right? the same way most everything in Python really is that you're interacting and working with an object that has methods and properties and all these attributes and things you could work with that are really under the hood, right? Functions and variables, just with a kind of a different decorated name. But being object-oriented means we can do some kind of nifty things with it. Maybe not all the time. I'm not trying to say OOP is the way, but it's nice to have that kind of built into the language when necessary. So you can see I'm working in like a little bit of a script here, right? I've got a shebang line set up. I'm going to work with Python 3 as my interpreter, and I'm going to use that from scapy.all import everything, or the asterisk, the star, the wildcard, to pull in everything that Scapy module has into my current namespace, so I can interact with it and I can work with it through Python. So here I'm going to create an object or a little variable, ping equals, and the IP, this big class name, right? You can see the capital letters there. That's going to return a Scapy object, and it's going to be a packet, and I can define how that packet looks. Maybe I don't want to use an IP, or maybe it's that specific header for that protocol. I could zoom in on other things between TCP, UDP, HTTP, or anything else. And Scapy already has support for all those crazy cool protocols and layers, and you could just pull them in and work with them. Or if you really wanted to, you could go do a little deep dive, get in the internals, and build your own. So note inside here, I'm creating this IP object, and I'm passing in a keyword argument. I'm saying DST, or the destination IP address. I've simply set that to a string, 192.168.1.1, and I've had a little division symbol, or that forward slash, which looks weird, right? Because we're not dividing these objects, but I'm using that syntax, and that is the syntax that Scapy uses to actually add layers in or kind of build them into that packet that we're crafting. So now I'm going to say this is simply going to be an ICMP packet or ping packet, right? I've assigned that to that ping variable or the object, and I'm just going to print that out on the screen. If I were to run that script, check out down below. Now I have that kind of B prefix to note that this is a binary string, or I'm just including real raw bytes here. And that \x, the \x everything, all those are the bytes to this packet that I've just formulated and created in a super duper simple way, right? It literally took one line of Python code, and now I have a ping packet. And I could do this. I could send this packet. I could receive the information that comes back, maybe a little echo, a request, reply ping. That's very, very cool. All in a script, all automated and extensible, whatever way that I want, and super duper short, right? One line of that Python code, easy to read, easy to write. Obviously, Scapy is abundant, and there are more examples of this sort of thing on their website and their documentation. And that's really, really why I'm pointing you all towards it, because that's where the good stuff is. We're going to cover some cool stuff in the talk, but if you want to go deeper, learn more, do some more research, I'd recommend, hey, go check out that documentation. Okay, last slide on Scapy, I promise, then I'll shut up about it and we can move on. I'm not trying to sound like an evangelist here, but I am trying to show to you all of the cool things that Scapy can do. Obviously, in this last slide, we just looked at a super duper small, minuscule example of one thing that Scapy could do. What we could do with that makes it so awesome is that it can all be automated and you can write it and you have that fine-tuned control all within Python. You have the entire arsenal of the Python language and libraries, modules, other tools that you can use and pull into it. So that's super duper cool. Now let's get into the good stuff. Let's get into the really cool attacks that could potentially take down the internet, right? So we'll start small, we'll start with some simple things, and then we'll slowly kind of zoom in onto more complex stuff. But just to kind of whet your appetite, let's start with the ping of death. Interesting name, right? So the ping of death attack is a denial of service attack where the attacker will stop a machine by sending a large ping packet. So large, in fact, that the machine can't handle it. It'll choke. There's so much data in that packet that the machine doesn't know what to do with it, and it'll freeze up or just fall over or crash. We talked about ping packets in the previous example, or that script and source code that I showed you earlier, when we were looking at that ICMP protocol, or the Internet Control Message Protocol. So typically, ping packets are very small, but IPv4 ping packets can be much larger, up to the maximum allowable packet size of 65,535 bytes. Some systems might not be designed to actually handle packets larger than this maximum, and they might be vulnerable to packets at that size, and they're sensitive to it, they'll choke, and they'll fall over. When this large evil packet is sent from the attacker to the victim, the packet becomes fragmented into different segments, each of which will be smaller than the maximum size limit. When the target and victim actually attempts to put these pieces all back together, eventually that total size will exceed that maximum size limit, and maybe a buffer overflow occurs or something goes wrong and that machine can't handle it. It'll freeze, it'll choke, it'll crash. So we're using this example where the ICMP echo or that ping packet could be used for this attack, but really anything that sends an IP datagram that can hold more data or can have this attached information that extends beyond that maximum size could be used for this attack. That could be TCP or UDP or any IPX stuff. Admittedly, the ping of death attack is kind of old and a little outdated, but I think it works as a really cool and simple, quick jumping off point or starting point for us to take a look at some of these evil, nefarious things that we could do with Python and Scapy. So with that said, let's take a look at the source code here. You can see I'm using the send function, which is part of Scapy. We say we've imported everything into our namespace. You could also send just one packet and receive the information back, or send packets inside of a loop. But for just one quick shot, firing the gun, we can use this send function here. We'll create a fragment, as kind of we discussed earlier. Okay, sending fragments that might be rebuilt and reassembled by the victim machine that could potentially cause it to crash and choke. And inside of that, we'll build this ICMP packet just as we've done before in that previous example. However, you can see there at the end, we use another divider or to add in another layer or some more information into this packet. And I just use a simple dummy string. I just use the letter X and I multiply it by this large number. So I have this data payload, this information that I've strapped to this ping packet so that I can send a ping of death that's just a little too big. And maybe that machine is biting off more than it can chew. It'll choke and it'll fall right over. I did mention, though, that this ping of death attack is less common today, right? More so now, you'll see other kinds of attacks that are still this denial of service attack, right? We're being a jerk. We're overwhelming, flooding, and just bogging down the resources on that victim or target. So one of the more common ones you'll see now is perhaps an ICMP or a ping flood. And we can certainly send other kinds of floods. One of the most common ones you might see is a SYN flood. SYN flood is another denial of service or DOS attack, which will make that server, your victim, unavailable to respond. It'll be just too busy. It'll be bogged down. It'll be hosed because something will be consuming all of the available server resources. We're going to cause that by sending packets with that SYN flag set. So you know TCP packets, right? TCP being the transmission control protocol, which ensures there is a connection in place by using the three-way handshake, right? The client on one side of the conversation will send to the server a packet with the SYN flag set to synchronize or start the conversation and begin requesting communication. The server over on the other end of the conversation will say and respond back with a SYN ACK packet or a packet sent with those flags set. Finally, the client, knowing that the server has responded, that someone actually answered the phone, it will respond once more with an ACK flag set on a packet, or the acknowledgement, okay, someone is listening and we can talk, we can have this conversation. Interesting thing though, on step 2 of that process, or in the middle of the three-way handshake communication, The server, while it sends that SYN ACK packet, it will wait to receive that ACK packet from the client so that it can begin having this conversation. So the attack is simple. We just send a ton of SYN packets where we're just starting all these conversations. We're dialing the phone, but once someone answers, we don't care. We don't respond to them with an ACK packet. So they're overwhelmed, right? The phone keeps ringing. They're going to pick it up and they're going to want to talk to someone, but no one will be there. They're just not having this conversation, but they're still holding the phone and more are ringing. That will hog all the resources. That will cause that target victim to not be able to respond to other legitimate traffic because, okay, hey, they're busy, tied up with other stuff. All those resources are being utilized right now. Because this attack brings that server to the halfway point in the three-way handshake, right? They've started the communication but have not responded to the server's acknowledgement. That means that it's halfway communicated. That's why it's called that half-open attack. Kind of interesting. So let's take a look at the source code, right? Scapy, again, makes this super duper easy. We're performing this attack in, realistically, 2 lines of code that could even be shortened to 1 because, hey, maybe we could abstract out that object that's not necessary for that SYN flood. We could just pass that to the function. So I'm creating the SYN flood object or variable, right? I send in a keyword argument for the destination. Again, just an IP address we'll use. We'll set an ID number for that packet and we'll specify the time to live. These values aren't extremely important for kind of just our discussion, but obviously that next layer certainly is. We create a TCP portion of this packet, and that sport, or S port is how you should read that, for our source port, that's just going to be a random ephemeral port that Scapy will help us generate with that rand short function there. That'll return something that make it look like, okay, we're coming from a different port every time. The D port, or the destination port, will be passed in as a list or a little Python array. We'll just send this over to port 80 HTTP. You could specify this to whatever you wanted to, maybe SSH or anything specifically. Specify a sequence number, specify an acknowledgement number. Again, for this example, those don't really matter all that much, but maybe they could in other scenarios. The window size, and the most important thing here, the flags that are set on this TCP packet. Obviously, I'm just passing in a string here with that capital S, and certainly enough, that stands for SYN, right? The SYN flag has been set on this packet. So we have created one packet that is just a SYN packet. The very, very first step in that TCP three-way handshake. The next line below, we're going to end up using that SR loop function that Scapy makes available to us. And that is going to send and receive packets in a loop. So we will repeatedly, over and over and over again, send this packet. The keyword arguments there, that inter or the interval, we'll send those at 0.3 of a second. We'll retry every 2 seconds if that kind of gets dropped. And we'll have a timeout of 4 seconds. Again, those are a little extraneous, but the point that we're getting across right now is that we are looping a SYN packet being sent over and over and over again. We are flooding that target victim server with this SYN flood attack. In the case of the line of code there, we have an answered and unanswered information that's being stored as a return value of that SR loop. That'll just return a tuple, okay, or a list of what packets actually had a response and what didn't. The point that I'm trying to get across is that just these 2 lines of code are putting together this attack. And it's super duper simple. All you've done is outlined the structure. You've orchestrated this packet, and now you can put it to work. You can weaponize it as a SYN flood. You might notice, though, in this example, with this setup right here, we're sending this SYN flood attack just with our attacker machine. One machine. So potentially, that endpoint or that target, the victim server, once it realizes, hey, I'm under attack, right? I'm in danger. If they kind of had the opportunity to look through some logs or could figure something out and determine, oh, I know the source of this attack, I can just make it a little bit harder to argument as an actual C with Scapy. And we can use that as a segue into the next attack, DNS amplification attacks. A DNS amplification attack is a really interesting technique that abuses the regular functionality of DNS, or the domain name system, to again overwhelm, spam, and flood a target or victim machine. The way that this works is that the attacker actually sends a legitimate regular request to a DNS name server asking for as much information as they can. So their request is a regular kind of small, tiny packet just asking for information, and the domain name server will respond with as much information as possible, and that way you get a much larger packet in response. The trick here is that with this DNS amplification attack, the attacker sets their IP address, the source, back to the actual victim or the target server that they're aiming to overwhelm and choke. You can see this here in the source code, right? We're defining, again, another object or variable to keep track of our packet. We're defining an IP header, but interestingly enough, we supply that src keyword value, or the source IP address of the packet that we're going to be formulating. Note, this will act as our victim. This is the target machine that will have the domain name server send back that large request. You can see again our division symbol or the / to add new layers, and we're adding a UDP packet portion, right? We'll set the D port or the destination port to 53, the default port for the domain name system or DNS servers. And what we're going to query from this DNS is anything we'd particularly like. Here, I'll just ask for anything regarding google.com or that domain. You could, of course, ask for any type or any resource record you'd like, an A record, a text record, a CNAME record. Generally, with this attack, you could expect to see the attacker request for any, as in return all of the resource records you could give me. We'll have that packet formulated, stored, and encapsulated in that DNS amp object and variable, and again, we will just send that packet along. The DNS server will respond accordingly. It will give all the information it can, but send it to that source IP address, not our actual attacker. That will flood and overwhelm, choke that target victim server. Obviously, you'd want to have more than one attack or one attacking machine doing this. You could perform this distributed denial of service, right? That DDoS, or send this request multiple times. But I think this attack is really cool and really interesting, right? If you put it in kind of layman's term or a normal human explanation, say you are at the drive-thru ordering some fast food to go or whatever the case may be. Let's say you ask the person or the teller that's chatting with you and taking your order, I want one burger or I want one drink or whatever. Typically, that job of the teller will read back your order, right? So envision this scenario. You as the driver, right? You as the attacker, you say, I want everything on the menu. And then before they can read your order back to you, you drive away and let that next person go ahead and actually hear all that information. So while you just asked for a small tiny thing and a simple, hey, give me everything you've got, the next person or your target or your victim is going to be read and enumerated and receive all of the information. So maybe, I don't know, what a 1 scale for your packet could respond to a 10 in the response and what that teller will read out to that other person or that individual. Kind of cool. And obviously, another added benefit to this is that the attacker is performing this attack indirectly. They make this request out to an open and accessible DNS resolver, and it will respond and just send that information out to the actual target or victim themselves. The attacker doesn't really leave any fingerprints or a trace on the target. It's not reaching it directly. It is an indirect attack. You can see that here again with that syntax, but as always, Scapy is making this really, really simple and honestly really easy. Okay, now let's talk about our finale attack. I want to discuss BGP abuse.